Hello, welcome to Module 2, Video A. In this video, we'll be going over Matplotlib and how to use it. When it comes to graphing in Python, Matplotlib is your base package. So we're going to go ahead and import it along with pandas and NumPy. In this video, we'll be using the dataset that we cleaned and condensed in the last video, which is this weather dataset. So reading it in and printing out the head, we can see that we have our index, we have a date, and then we have a variety of different weather information. We have the summary, which just gives kind of a snapshot of what the weather was like. We have precipitation type, humidity, wind speed, all of these different variables. And we'll be going through and seeing how to use graphs to actually visualize and get a look at this data. So when it comes to Matplotlib Basics, the general format that you use to plot a graph is that you're going to initiate your graphic, you're then going to add additional elements to it, and finally have a command to show your graphic. So first off, to initiate our graph, just using the very basic function, it's going to be plt. If you look up above, we said import matplotlib.pyplot as plt, so that's just kind of our abbreviation we can use instead of having to type out the whole library name. So it will be plt.plot, and then the first two arguments that you're going to pass in here are going to be your x values and your y values. So in this case, I want to use the index values as my x values, so that's just going to be, integer values. And then I want to take a look at the temperature data. So then I'm going to also go to my data frame, and I'm going to select the column which is named temperature, Fahrenheit. And let's see, temperature. There we go. Okay. So that right there initiates the plot. And then to show the graphic, we're going to say plt.show. So that right there is probably the very simplest plot you can make. So we see along our x-axis, we have those integer values that came from our index. And then along the y-axis, these are the temperature values. We're plotting over quite a few years here, so you can see how it goes up and down with the seasons. One quick note, if you fail to provide two arguments for the plt.plot function, if you just provide one argument, it will default that to y. So I can actually take out my x values and just put in my y values, and it'll just kind of make an assumption there and plot along integer values. But for this case, we'll go ahead and add that back in. Okay, so this is our very basic plot, but there's not much there. There's no axis titles. We know what's here, but nobody else would. So we're going to go down and add a few more things. So here, this is just copy and paste it in, except I've done one thing. For this next graph, I want to look at just 1 year of data. So instead of selecting the whole columns, you can see here that I've just selected entries 0 through 365 of both the index and the temperature. So if we plot this as is, we see we now only have 1 year of data. However, what we're also going to do here is add in some labels. So first off, we want an x label. So that's going to be plot.x label. And then just the string we want to do. So for this, I'm going to say days because that's what our unit is along our x-axis. And then we're going to do y label the same, except y label. And for our y label, let's say degrees Fahrenheit, since that is what we are in. And then I'd also like to give it a title. And to do that, it's going to be plt.title. And again, passing in a string. If you don't pass in a string, it won't like it. Daily temperature at noon. If you watched the previous videos, you would have seen that our dataset originally included a row for every single hour of the day. So for every single hour of the day, 24 hours, it had a row. In this condensed dataset, what we did is we just selected each, the row that was taken at noon from each day. So that's why our title here is going to be temperature at noon. Let's see, so yeah, I've added that in, and we'll go ahead and run the graph. And you can see just like that, it adds in our labels. This is looking better, but we could still improve this more. So I'm going to go ahead and copy this down. And what we want to do now is modify the axis limits and the frequency of the tick marks. So on our x-axis here, our tick marks are actually looking pretty good. But maybe we say, okay, well, we want to include 0 because that's freezing. You know, for some reason you want to include that, we can do that. So what we do there is we specify it using xlim. So xlim, oh, whoops, can't forget the PLT. plt.xlim. And then, so xlim is going to take in, oh, sorry, I'm backwards here. I want to do my ylim first. We'll get to xlim. Ylim, that's what we're looking at. So this function can take in any list. So I'm going to say that I actually want to go 0 to 100. I can run this chunk, and we see that below, it's now just at 0 to 100. My ticks are kind of looking far apart now, though, so I would like more frequent tick marks. So I'm going to go plt.yticks. This function can also take in any list. I could go and specify each tick manually, but instead I'm just going to go ahead and use the range function and say that I want my ticks to range from 0 to 100, and I want them to be spaced every 5. So now if we run this, oh, it didn't like that. What did I do that it didn't like? plt.yticks. Oh, I kept my brackets in there. Those are not needed. Okay, there we go. Quick note here, you'll see that it actually only went up to 95. That's just because of how the range function works. It doesn't actually go all the way up to the top that you give it. So let's give that 101, and there we go. Now we have our 100th tick right there. So that's our y-axis looking pretty good. I would really like my x-axis to make a bit more sense. Days of the year isn't bad, but it would be a lot more useful to have months. For this, I'm actually going to copy in a chunk of code just because it takes a little bit to write. What I've done here is using the xticks function, I've given it 2 lists. So my first list here specifies where I want the xticks to be. And what I did to generate that is I actually went through, so 0, that's the first day of January, 31 corresponds to the first day of February, and so on and so forth. I went through and actually manually added how many days were in each month. If I just wanted to approximate this, I could have used the range function and had it go by intervals of 30. But yeah, so that's my first list, is where my tick marks are going to be. And then the second list I passed it in is what the tick marks are going to be labeled. So we can see that when we run this code, now our x-axis actually shows what months we're in, which is really useful. Do want to go back and change my x-axis label now, since it's no longer days. Instead, we're going to say months. And then one more thing I want to do to make this just a little bit more readable is to add a grid in. So plt.grid. And now, oh, what didn't it like? Oh, I misspelled grid. That's what it didn't like. go. So now I had a grid. So now you can go through and you can read off specific values. So I can see, okay, 1st of April, looks like the temperature at noon that day was about 63 degrees. Really nice day in April. One more thing we'll do working with this basic plot is I want to go ahead and show you, that's not what I wanted, how to graph multiple variables. So right now with this plot, obviously we're graphing one variable, but you can graph more than one variable on the same plot at a time, which can be really useful. So we've got this one here, and to add another data set, you just add another plt.plot function call right there. I'm actually going to just copy this one down because that will be easier. Okay, so what we've been plotting is temperature in Fahrenheit. There is another column in this data set that is called apparent temperature. And I'm curious how those two differ. So apparent temperature. Now if I do it just like this, there we go. So this is actually automatically just assigned it some colors. Don't really know which one right now. I'm going to go ahead and manually assign colors. So up here in these, I'm going to give it an argument that is B dash. So that means this one is going to have a blue line. And I'm also going to give it a label. I'm going to say label equals measured temperature. You can tell spelling is not my forte. Apologies here. There we go. Okay, and then we're going to do a similar thing for this one. I'm going to go ahead and give it a red line. And then for its label, we're going to say apparent temperature. There we go. Oh, and need our equal sign. Okay, so that's going to reassign the colors, but you still know which ones are which. So the last thing that we want to do is add a legend. So we can do that, just plt.legend. And there we go. So now we have both graphed. We can see that a lot of times they overlap, but often the measured temperature is just a little bit higher than the apparent temperature, which I believe for this data set is a sort of feels like temperature. So yeah, that's the basic of Matplotlib, and we'll sign off here, but in the next video we'll be looking at scatter plots.